All right, so the bonus question said we're supposed to find k, so that's our goal, k equals something, so that this line, y equals 4x minus 9, is tangent to this function. So this is a parabola, and then we're going to have a line that is tangent to it. So what you need to do is find the derivative. We're going to get the derivative of this, and the derivative gives you slope of the tangent line. So hey guys, what is the slope of this tangent line? Because that's what we're going to use. So everybody, what is the slope of this line? Review from algebra class here. 4, good, awesome, 4. 4 is our slope. Nice job. So we're going to set the derivative equal to the slope. So we're going to get this derivative, which would be 2x. K is just a number. K is a constant. Like this is going to be some value. So the derivative of that would be nothing. That's going to go away. So we're going to take this derivative and set it equal to the slope. Derivative means slope. So we're going to have 2x equals 4. And so x is 2. And I know you're probably like, Ms. Cole, who cares what x is? We want to find k. Okay, I get it. But we're going to have to get x and y first before we can get k. So if x is 2, we found that, we know that. I'm going to plug 2 in right here to get y. So 4 times 2 would be 8, minus 9 would be -1. So we have x and we have y. And I'm going to plug those both into this function to solve for k. So f of x, or you could say y, that's going to be -1. So we're going to have -1 equals x squared. So that would be 2 squared, which would be 4, minus k. And so I'm going to subtract over the 4. -5 equals -k, and so the negatives cancel. So this was the answer, k equals 5. And let me just show you on a calculator real quick what that would look like, because I had some people try to draw it, which was, you know, a good effort, but if you didn't have the k equals 5, I didn't give, you know, any bonus for that. But let me show you what this would look like. So I go to y equals, and I'm going to type in this function. So it would be x squared minus 5. So that's going to be the parabola, x squared minus 5. And then I'm going to also type in this tangent line, so 4x minus 9. And I'm going to hit zoom 6. And you'll see there's the parabola, move down 5. And then that's the line that's tangent to it. So you can see that that line is tangent to it. So it just comes by and kisses the graph at that one point. But honestly, guys, the bonus was the only one that like people really didn't answer or struggled with. The rest of this was pretty much okay. So I'm just going to open it up to you guys, and I'll do a few. Again, I can't do them all, but I will do a few. So if you just want to type in the chat which ones you want. Okay, the one about the cone is number 6. All right. So we were told the cone is filling up 2 cubic feet per minute. So that is dV dt. And you can use the units as a clue. The cubed means we're talking about volume. So that is dV dt. And we're told that the radius is 1/3 the height. So r equals 1/3 h. And we are asked for the rate of change of the depth of the water. So I'm going to call that dH dt. Some people use d for depth. I'm just using h because in the volume formula, it's an h, just the water level, okay? And it should be positive because it's filling up. And it says when the depth of the water, so when the height is 5 feet. So that is all the information. This is the volume formula for a cone. That was provided to you on the test. You didn't have to memorize that. Now the issue is you have R and you have H, and you have no information about R. So you're going to have to use this to substitute that out. So in place of R, I'm going to put 1/3 H. So I just took out R, I put in 1/3 H. And then I'm going to square everything that's in there. So that is going to be 1/9 H squared And then lastly, I'm just gonna multiply this stuff together. So 1/3 times 1/9 would be 1/27 pi, and then this would be h cubed. So we had, those 3 steps of algebra to get this r substituted out of there, and now we can go ahead and do the derivative. So dv dt equals, and we're going to bring this 3 down. Now you can just leave it as 3/27. I'm going to reduce it because most of you did. 3/27 would be 1/9 pi h squared dh dt. But again, if you left it as 3/27, perfectly valid, totally fine. And then we're just going to plug everything in. So dv dt is 2, and h is 5. And all you have to do is divide all of this stuff to the other side. You don't have to simplify any of it down. You guys did a good job with this. Just leave it all alone. Because at that point, it's the grader's problem. Like, that's my problem at that point, to look through that and make sure that it's correct. You don't have to do any more work for that. Last thing we just need are units, and it is going to be feet per minute. The cubed was because this was volume. We just found a rate for the height, so it will just be feet per minute. All right, and then I see 4 written in the chat, so we'll go and do number 4 as well. Oops, sorry, that made kind of a loud noise there. All right, so this is asking for the instantaneous rate of change. That just means the derivative at 2, 0. So you don't need to write a whole equation, it's just the derivative at this point. So basically just the slope part of the equation at that point. So derivative of 3y is 3 dy dx. Minus 7 is a constant, so that is gone. Derivative of cosine of y is negative sine of y. And then again, dy dx. Every time you do a derivative with a y variable, you have to multiply on a dy dx. And then minus 4x. The only thing I am remembering about this one is a lot of people left out the y. Just remember, you can't have sine of nothing. Like, it would have to be sine of a variable. So you have to leave that y in there. And then we're going to plug in the points. So we're going to put in 2 for x and 0 for y. So this will be 3 dy dx equals. Now, if y is 0, sine of 0 is just 0. So this entire thing is going to just go away. That whole thing is just going to be 0. Minus 4 times 2 would be 8. And then your last step is just to divide over the 3. So it would be negative 8 over 3. All right, and I'll do a couple more if you guys would like to pick another one. You can type it to me privately if you want to. Is there another one that you guys want to look at? I'm scared the second I stop the video, someone's going to be like, oh, wait, do this other one. Are you guys sure? Okay, number 8. All right, so this was the baseball problem. So here's your baseball diamond. It's 90 feet on each side because the bases are not moving. No one's running around with them. A batter runs from second base to third base. So here's second, here's third. He's somewhere in between here. This is not to scale. I just stuck him somewhere in the middle, and he is running that way. And it says he's running 25 feet per second. I can't label that yet because I don't have any variables written in, so we'll come back to that. Find the rate at which the distance between the player and home plate is changing. So I'm going to connect him to home plate. And so this is the triangle that we want to focus on, and now I can start to label some of this stuff. So this distance is 90, that's not changing. And I'm going to use variables for the other two sides. I'm using x and y. You could have put x here and y here. You could have called them a and b. It really doesn't matter, whatever you want to call them, but those have to be variables. And now I can go back and label the rate of change for the runner. It said he was running at 25 feet per second, and that's going to be our dx dt. That's the rate at which this distance is changing. And it's going to be negative because as he's running this way, that distance is decreasing. It's getting smaller and smaller. So negative 25 feet per second. We're asked for the rate of change of the distance from him to home plate. So dy dt is our question mark. And hey guys, should it be positive or should it be negative? What kind of result are we expecting for this? And yeah, good, thank you. Yes, it will be negative. I know he's not running directly towards home. You can't like skip third base, but as he runs this way, he is getting closer to home. So that's gonna be a negative rate. And then it says, at the moment when, so we have to pause, when he is 20 feet from third base. So that's when x is 20 feet. On the one in the study guide, I gave you like this distance and you had to subtract it, but on the test, I just went ahead and gave you that. It's he's 20 feet from third base, that would be this, so when x is 20. All right, so Pythagorean theorem, this is gonna be x squared plus 90 squared, so 8100 equals y squared. And then the derivative, so 2x dx dt, this is a constant, so it is gone, equals 2y dy dt, and then the 2's are going to cancel. And then we're ready to plug stuff in. So x is 20, and dx dt is negative 25, and y we're going to have to come back to, so hold on for that. And then dy dt is what we are looking for. So I'm going to go back to this original relationship and we'll plug in what we have. So x is 20. 20 squared would be 400 plus 8100 equals y squared. And so that would be 8500. And it's not a perfect square, so we're going to leave it alone. And even if it was, you can still just leave it as square root of whatever. And so the only other thing you have to do is divide that over. So this is going to be 20 times negative 25 over this square root, and the units are feet per second. That one overall went well too. Some people missed the negative sign and that was it. But yeah, I don't have any notes on that. It went okay. I'll do one more if you guys would like to pick another one. Okay, I'm gonna stop the video. Is that okay, everybody? No more questions? Okay, I'm gonna go ahead and stop.